So, we're going to talk about the scientific method. And where we're leading to with this is probably tomorrow, maybe Monday, depending on how today goes. We're going to get these little roly-polies out. And they're live. And you're going to design an experiment using what we talked about today to determine what kind of environment they like. Do they like hot or do they like cold? Do they like wet or do they like dry? Do they like light or do they like dark? You're going to have to pick one of those kinds of scenarios and design an experiment. Go ahead. Good. Don't touch it. So before we do that, this is just kind of a simple intro to how to design an experiment. Let's talk about the steps of the scientific method. Our question, you should always start with asking a question. Step number one, if you're a scientist. Our question is, what kind of environment do pill bugs like? And in particular, we're probably going to ask the question a little bit more exact. We're going to say, do pill bugs prefer wet or do they prefer dry? Or do they prefer hot or do they prefer cold? Do they prefer red or do they prefer blue? You could ask all kinds of things. And I'll let you go in lots of different directions with the kind of environmental thing you're looking for. Then you do background research. Now, tomorrow we're going to skip step 2 intentionally. Because if you were to Google pill bugs, you could probably find the answer, right? To what we're doing. We're doing something really simple. So we're not going to do that part tomorrow. But realize that a normal scientist, you got to stay up, would go through and research everything that's been done. He would do internet searches. He would read through journals. Because it doesn't make sense, if you're a real scientist getting paid money to do this, that you're doing things that people already know the answers to, right? It doesn't make sense. Then you're going to do a hypothesis. And like we said yesterday, you always want to write your hypothesis in that if-then form. And I want to talk specifically about 2 kinds of variables, independent and dependent. Let's say that you're growing. Well, let's say you've got an aquarium. So you've got an aquarium, and let's say somehow you have it so that you've got like a heating element over here. So you got some heat over here, and there's no heat over here. So let's say that this is like an imaginary middle line in the aquarium. Let's say this side's warm, and this side is cool. And you put your fish in the aquarium. You start them all out in the middle. You put them all right here. And then after, every 5 minutes or so, you count how many fish are over here and how many fish are over here. How might you write a hypothesis for that? Well, actually, before we do that first, what would be our independent variable in that experiment? We're looking at 2 things, right? We're looking at the temperature and how many fish. Which one is independent? Up here in fish, and here in temperature. Think for a minute. Do the fish determine the temperature? No. Does the temperature determine how many fish are there? Yeah. Okay. So which one is independent? Hold on. Think for a second. Think for a second. We're looking at the temperature of the water, and then we're looking at the number of fish. Now think about the way I'm saying this. Do the number of fish have an effect on the temperature? No. That means the temperature is independent of the fish, right? Do the number of fish in a certain spot, are they dependent on the temperature? The number of fish that go here and the number of fish that go here, is that dependent on the temperature? Yeah, they're picking which one they want to go to, right? This is determined by this, not the other way around. In an experiment, the independent variable is the thing that you're changing and trying to test. In this particular experiment that I explained to you, we're trying to test the effect of what? The effect of the temperature on the fish, right? That's what we're trying to do. So in this particular experiment, our independent variable is the temperature of the water. The dependent variable is the thing that changes because you intentionally changed what? The independent variable, in this case, the temperature. The number of fish on each side of that tank are going to change because the temperature is different, right? That's the dependent variable. So let's just talk about another experiment for a second. Let's say you're growing plants. And some of the plants, you just put regular old dirt in. Other plants, you add different amounts of fertilizer to. And after a few weeks, you measure, what might you measure about the plants? Their height. In that experiment, what would be the independent variable? How much fertilizer you gave them, right? Or if you gave them fertilizer at all. And the thing that changes because you change the amount of fertilizer is what? The dependent variable, which in that case would be the height of the plants. Does that make sense? So when you're writing a hypothesis, you're going to write it like this. If I do, now where the word this is here, you're going to explain what you're doing. So for example, in the fish experiment we were explaining, we might say if we make the water in an aquarium warm, if we make the water on one side of an aquarium warm, then what do we think might happen? More fish will go to that side. Or you might think less fish will go to that side. So you say, if I do this to the independent variable, here's what's going to happen to the dependent variable. If we were talking about the plant experiment I just described, we might say, if more fertilizer is added to the soil around the plant, then what? What's fertilizer going to do to the plant? Then it will grow more, grow faster, something like that. That's all we're talking about. Some people write a hypothesis as a question. That's not how we're going to write it. We're going to write it as a statement. Now, you're writing a hypothesis before you do the experiment, right? So is your hypothesis always going to be right?
That's what you think will happen.
Yeah, it's just what you think will happen. A lot of times you do the experiment, you find out that was not really what happened, right? Is that okay? That's perfect. That's perfect. Because what's the purpose of your experiment? To test the hypothesis. Is it right or is it wrong? You shouldn't know going in. Okay? The purpose is to answer that hypothesis, right or wrong. An answer that your hypothesis is wrong is just as good as if it's right? Because you answered the question. You know, yeah, it's true or yeah, it's false. Either way. So after you've got your hypothesis written, you're going to test it. And remember, the whole purpose of this experiment is to test that. As you're testing it, you're going to collect data. And there's two kinds of data that you're going to deal with in an experiment. Anybody know the two kinds of data you're going to be dealing with? These are some words you need to know, and you need to write them down if you don't know them. There's one kind of data that we're going to call quantitative. What does that mean, quantitative? What word does it sort of look like? Quantity. Which means it's numerical. This is numerical data. So if in the fish experiment, what would be our quantitative data?
Number of fish.
The number of fish on each side. In the plant experiment I described, what would be our quantitative data?
The amount of
The height of the plants. That'd be the quantitative data. Whatever that is, let's bring that off. Yeah. Numerical data. Numerical data. Now, on the other hand, qualitative data is the other kind of data that we're going to deal with. Qualitative. Qualitative kind of sounds like quality, right? Quality of something. Qualitative data is when you describe what's happening. Most of the time when you're doing an experiment, you might describe how the fish move, how fast, where do they go exactly in the tank. You might describe what the plants look like during that plant experiment. Did the colors of them change? Did the leaves get darker? Did they get more leaves? So it's word data, descriptive data in sentences. You're describing what's happening. So this one's all about numbers. This one's all about words. In a good experiment, you want both. You need both quantitative and qualitative. Yeah. Quantitative is numerical data. Second. Qualitative is descriptive. Like you're describing what's happening in words during the experiment. All right, after you've got your data collected, you're going to analyze it. You're going to have to do some math. You're going to have to draw some graphs. You're looking for patterns, right? When you're looking at your data, you're looking for patterns. You may take like the average. You may take, there's a lot of fancy statistics you can do, but we're not going to get into most of those statistics. What's the purpose of like the mean, the median, and the mode? What are those sometimes called as a group? Yeah, what are they trying to find? The mean, the median, and the mode. What are all three of those trying to find? What's the middle, right? They're looking for the middle. What's that? The middle number. That's kind of what we're looking for. A lot of times we'll do those when we're doing an experiment. And then you come to some conclusion. Yeah, my hypothesis was true. No, my hypothesis wasn't. That's usually going to be your conclusion. And then if you're a real scientist, you have to communicate that out. You have to tell people, because it doesn't make sense if you did an experiment not to tell anybody, especially if you discovered something important, right? How do scientists communicate out their results? They publish in journals. They may do a poster presentation, like some of these posters you see over here on the wall. And they'll take those to like scientific meetings, and then they will explain their poster and talk about it. It'll be like a little talk about their poster. Especially newer scientists that are just getting started, that's a lot of how they first publish them. They do these posters explaining their work, and then they'll give a little short talk about it to other scientists. All right, that's the general scientific method stuff. Anybody have questions there? Shouldn't be anything new to you. All right, let's see, we did that. Let's make sure we know the difference in these variables. Independent and dependent, first of all. Remember that in an experiment, the independent variable is the thing that you are changing or manipulating on purpose. It's the thing that you're testing. And in a good experiment, you can only have one of those. Let's say you wanted to know, you were testing plants, and you wanted to know what effect fertilizer had on plant growth, but you also wanted to know what effect different colors of light had on the plant growth. If you gave plants different amounts of fertilizer and different colors of light, and then you measured their height, do you really know which one was having an effect? No, you don't know. That's why in an experiment you only have one independent variable. What do you want everything else about those plants to be like? Exactly the same. You want to use the same kind of plant in all your plots, right? You want to use the same kind of dirt in all your pots. You want to use the same size pots. You want to make sure the pots get the same amount of light. They get the same amount of water. Everything is exactly the same except that one thing we're trying to test, which is our independent variable. Everybody good with that? Our dependent variable is the thing that we measure, the quantity that we measure, that changes because we change the independent variable. It's the thing that you're measuring during the experiment. So in the plant experiment we talked about, it would be like the height of the plant. In the fish experiment we talked about, it would be the number of fish on each side, the hot side and the cold side. It's the thing that you're measuring. It changes because you change the independent variable. And then we also talk about these things called controlled variables or constants. What those are, it's the first time we've mentioned those. Those are the things that you make sure don't change during the experiment. The things that are the same with every subject. And that would be things like, if we're talking about the plant experiment, same dirt, same pot, same amount of light, same amount of water. Because if any of those things are different between your pots, do you really know if it was that thing or if it was the fertilizer? You don't. You don't know. You only want there to be one difference between the things you're testing, and that one difference should be what? What's the one thing that's different? Independent variables. That's the thing you're testing. That's important. Everybody good here?
No.
Still right? Okay, keep going. But make sure you know the difference between those three things, because on your first test, there's going to be several questions. If you know that slide, it's probably worth 3 questions on your next test, just that one slide. Know the difference between independent variables, dependent variables, and controls or constants. Can I move along now? No? Okay, keep going. Another thing to remember while you guys are doing this, I'm posting these PowerPoints on Edmodo, so if you happen to miss something, you can always pull it up and copy it straight off. It'll be there for you. Try to make life a little easier for you, so there's no excuse when you fail a test. You'll have me talking, you'll have PowerPoints, you'll have charts, and I'll send a message to your parents reminding them that all those things are up there for you to use. By the way, if you have not done the Edmodo sign-up thing, you need to do that. Tomorrow, I'm giving you a grade for 2 things. Number 1, you signed up. And number 2, your parent followed those directions and signed up with you. So make sure you get that done. Talk to me after and we'll work on yours. All right. That's really hard to read, so we're going to skip through that. Let's talk about how you set up an experiment the right way. Good experiments are called controlled experiments. What does that mean? If you're testing like the effect of fertilizer on the growth of the plant, what's your control? Yeah, but what do you do to the plants that are in your control group? You don't give them any fertilizer. That way you know the ones that grow faster, it's called fertilizer, right? If you're testing the effect of light on plant growth, what do you do with some of the plants? You put them in the dark. If you're doing a drug study, maybe you're a pharmaceutical company, and you've developed this pill that you think is going to make people lose weight. You get people to sign up that are heavy. They sign up, and the first thing you do is you divide them into 2 groups, randomly. One group you give the pill to. What do you do to the other group? You give them a pill, but it's not the real medicine. It's like a fake pill, right? It's got sugar or salt or something in it. They think they're getting medicine, but they don't. Why bother giving them anything? Why don't you just say, hey, you're in the control group, you're not getting anything?
Unless they believe.
Your mind can do some weird things, right? If you think you're supposed to be losing weight, sometimes you do. Right? Subconsciously, if you think you're supposed to be losing weight, you may eat a little less. You may exercise a little more, just subconsciously, because that's the way our brains work. It may not be the medicine. So you want a control group to let you know if it's really the medicine or if it's the trick your mind is playing on you and making you lose the weight subconsciously. So, you want to? Yeah, it's pretty hard. Point being, though, any good experiment is going to have 2 groups. And that's why it's called a controlled experiment. It's going to have a control group and an experimental group. The control group, you don't mess with what in? What do you not mess with in the control group? The independent variable. You don't mess with it. They don't get the independent variable. If you're testing the effect of light on something, that control group doesn't get any light. If you're testing the effect of fertilizer on something, the things in the control group, they don't get the fertilizer. They just don't get it. It's like the 0 group. They don't get the independent variable. The experimental group, that's the one that you manipulate the independent variable with. You change it. You might have plants in the experimental group, and one might get 1 gram of fertilizer, and another might get 2, and another might get 3, and another might get 4. Is more fertilizer actually always mean better?
No.
You get to a point where what happens if you put too much fertilizer on something? Yeah, it'll kill it. Too much will kill it. Too much will toxic. So you want to vary the amount so you figure out what's the best, right? You want to figure out the best amount, the amount, the optimum amount. All right, another thing that you want to pay attention to is this right here, random assignment of subjects. Here's the deal. Let's say you're working for a pharmaceutical company. You're a scientist, and you're testing drugs for the company. If you're working for, say, big drug company, and they think they've developed the perfect diet pill. If that diet pill works, what's probably going to happen for you? You're probably going to get paid more. You're probably going to get a raise, right? So subconsciously, you're thinking what? I need my study to show what?
That it works.
That it works. Maybe even if it doesn't, right? So to keep people honest, one thing that they do is when people sign up to be in these tests, they usually have a computer to put people randomly into groups. Because you might look and you might say, man, that guy, he just looks lazy. He's not going to exercise. He's not going to listen. So I'm going to put him in the control group. But this person over here, man, they look like they're going to exercise. They sound like they're working hard. I'm going to put them in the experimental group because they're going to lose some weight. You guys pass it back to Aaliyah for me. Anyway, so you randomly put them in groups. That's important. That way the scientist is not subconsciously putting people that he think might do one thing in one group and might do another in another. For example, let's say you're working for a company that's making cancer drugs. And this is going to sound kind of cruel. Hear this for a second. Who's going to sign up to be in an experimental cancer study?
People with cancer.
Well, obviously. But what kind of cancer patients? The ones that have tried everything that's already been tested, right? So they're like on their last hope. They've tried everything, it hasn't worked, and they're dying. So they sign up for this experimental treatment. What's the first thing you do as a scientist when all these people sign up?
Sign them right away.
Yeah, but what do we say the first thing you do when you start an experiment? You divide them into what? A control group and an experimental group. What do the people in the control group get? Nothing. They're dying. They don't get any treatment. Right? Well, slow down, I'll explain. The people in the experimental group get the treatment. Here's the thing, you gotta have a control group, because if you don't, let's say you give this medicine and people start having all these crazy symptoms. You don't know if it's the cancer causing the symptoms or what? Or the pills. So you gotta have a control group. Maybe some people just die very fast. You don't know if it's the medicine that killed them or the cancer that killed them. That's what the control group's for. And those people know going in that there's a chance that they might be in the control group. And they're not getting medicine. That's part of being in a study. Yeah.
Do they have like some type of content?
Yeah, you have to get people with the same kind of thing. I'll get you in just a second. But here's the other thing. So you know that part of the people aren't going to get it, part are. If you're the scientist and you want this experiment to show that this drug works, you might be tempted to put the people that were more sick in which group? The control group, right? Because they would die. And the people in the experimental group, you might put the people that are more well in there, so it looks like they do better, right? That looks like your drug's working better, when really it's not. So to keep that from happening, the best way to do it is to have a computer say this person goes in this group, and this person goes in this group, and this random. That way the scientist can't cheat. You don't want the scientist to cheat. You want the scientist to be fair about it. Question.
How would that work? Because if you had two groups, say it's like they're on this area, if like if the drug worked for one half and they started getting better, what would the other half do? Because they would kind of see a difference, because it's easy to think, well, no, these are getting worse.
And that's the purpose. Well, no, the people know going in that they're going into a study and they may not be getting any medicine. They know that. If they see that a drug is not working super good, a lot of times they'll stop the study and they'll start giving it to all of them. But they have to have that control group to see if there are side effects, if it actually works, if it doesn't work. And that's the purpose of the control group. Another thing that has to happen in science is replication. What's replication mean? Yeah, you got to do it more than once. Sometimes you run an experiment, and guys have probably done labs where you do an experiment and it just didn't do what it's supposed to do, right? Sometimes that happens. To make sure that's not what happened in your experiment, you have to repeat it. The experiment has to be done more than one time, and hopefully by more than one group of scientists, just to make sure. Again, it's just a check to make sure it wasn't a fluke the first time. And remember, there are things you want to hold constant. If you're doing a drug study, what do you want to make sure is the case? What would be some things that would need to be constant in a drug study? You'd want to make sure that the people aren't taking what? Any other drugs. They just need to be on your drug. You want to make sure that the people are similar healths, right? Maybe similar ages. You want to make sure they're having similar activity levels. They're eating similar diets. You'd want that kind of as many things to be the same as possible, because otherwise it might not be the drug that's causing the change. It might be their diet or their activity level, or any of those things could be a factor. You want the only difference between the two groups to be the thing you're testing, your independent variable. Everybody good with that? All right. If you've done your experiment and you got all your data, and now you're ready to analyze it, one of the first things you're going to do is graph it. And most of the time it's going to be a line graph. Occasionally it might be a bar chart. Most of the time it's going to be a line graph. When you're graphing things, you're going to plot the independent variable as your x coordinate and your dependent variable as your y coordinate. For example, let's say we were talking about that plant experiment we were mentioning a minute ago about fertilizer's effect on what? Plant height. What was our independent variable there? Fertilizer effect on plant height. What's the independent variable? The amount of fertilizer. So, like we said, the independent variable is going to get planted on the x. X is the horizontal axis, right? So we're going to put fertilizer here. Usually you put the units after it, so we might measure the amount of fertilizer maybe in grams or something. So maybe this is 1 gram, 2 grams, 3 grams, 4 grams, 5 grams, 6 grams. And then the dependent variable goes on our y-axis, and this might be plant growth. And maybe we're measuring that in centimeters. And again, maybe it's going to be 1, 2, 3, 4, 5, 6. And then we plot out our points. We just plot our points, just like you would on any graph. Let's say we plotted them out, and our points look something like this. A lot of you would be tempted to do what when you saw those points? Come in and like draw a snake through it, right? Connect the dots. Is that the way you're supposed to draw a scientific graph? Is it a connect the dots
Like, you're
thing?
supposed to go like a straight line.
Yeah, you're supposed to draw the straightest line through those data points as you can, kind of like right through the middle. So it wouldn't be a connect the dots thing. It might look more like this. That's kind of through the middle of the points, right? Anybody know what we call that when we draw a line through the middle instead of connecting the dots? It's called best fit. A line of best fit. Yeah, that's good. And another thing you want to be careful of, notice that I started at my first point and I stopped at my last one. Do we want to go past that? Do we want to go before that? No, because if we do, what are we really saying? We're saying we know what happens if you go past this. We know what happens if you start before we started. Do you? No. If you do decide to extend your line on out, how do you let somebody know who's looking at your graph that, hey, I'm just guessing here? You make it dotted or dashed. So for anything you don't have real data for, you dot it or you dash it. just to let them know, hey, I don't really have numbers for this. I'm just guessing that the same pattern holds that way, and it holds before I started. Dot it or you dash it. All right, we're not going to deal with the slope thing just yet. I'm going to stop there for just a minute. We're going to come back and talk a little bit more in a minute. Let me turn off the recording here for a second.